All right, guys, let's talk about functional groups. So let's kind of give a little definition here what a functional group is. First of all, they are either atoms or groups of atoms that give an organic compound characteristic reactions. Let's take a look at it that way. Give an organic compound characteristic reactions. So they react in certain ways if they have these functional groups. That's what they'll do. If they have this functional group, and that gives it certain kinds of reactions that it can do or that it will do. Okay? And so we're just going to start listing them out over the course of the next couple of lessons and doing some practice with them. And so the first ones that we'll talk about are halogen substitutes, if you will. You might see this called a haloalkane or a haloalkene, it could be. Haloalkanes or halogenated alkanes or alkenes. And so let's take a look here. So if we have, we'll just start with the easy one. If we have methane, which is CH4, we could substitute an H for a halogen. And so, for example, we could take off one of the H's and we could replace it with a bromine. Let's put a bromine on there instead of an H. And so that now has the functional group. It has this halogen functional group, if you will. Whereas this is methane, we would now call this bromomethane, because we have replaced one of the H's with a bromine. And so we say it's bromomethane. And so your halogen groups are going to be fluoro, bromo, chloro, and iodo. That's how we're going to name them. We're just going to kind of change the ending to O on those halogens. And so let's take a look at another one. Let's take a look at methane again. But this time, let's substitute 2 bromines on it instead of 1. We have 2 bromines. Well, we're not going to call this bromomethane because it's different than the other bromomethane that we just drew previous. This is now dibromomethane because we have 2 bromines on it. So it's dibromomethane. If we add a third bromine, if we put another bromine over here, where maybe that H is, well, that's going to be tribromomethane. If we add a fourth one here, now we've taken off all the hydrogens and we have 4 bromines around it, that's going to be tetrabromomethane. All right, so let's look at a longer one. Let's say that we had a propane with all of the H's around it. And I'm not going to draw the H's in this case, but these are all full of H's. And let's say we take off one of those H's. Let's say we take off this H right here and we replace it with the fluorine. Okay, and let's do another one. And let's say this time we take off this H and put a fluorine there. Okay, so again, these are halogenated with fluorines, but the fluorines are in different locations, so we're going to name them differently. This one, maybe you can figure it out by now, is 1-fluoropropane. And this one here is going to be 2-fluoropropane, because we're going to identify where the fluoro is. Well, the fluoro is on carbon 1 in this case, because we're going to number this one from right to left, 1, 2, 3, because we're going to know closest to the substitute. In this case, it doesn't matter where we number from the left or the right, it's going to be the same either way, so 2-fluoropropane in that case. Okay, so those are halogenated substitutes. We are simply going to put the halogen in front of the main name, and we're going to add di, tri if we need to. We're going to add numbers if we need to. If we're getting a longer change, we'll add numbers. And we can have numbers and dis and tris as well. Let's go to the next functional group, which is going to be our alcohols. And so with an alcohol, what you're going to look for is you're going to look for a OH group bonded to a carbon. A C bonded to an O bonded to an H. So if we drew that out more, you'd have a lone pair on the oxygen and then bonded to the H. We don't need to draw the lone pairs when we draw organics though. So this is what we're going to have: a C bonded to an O bonded to an H, and that OH is a hydroxyl group. That's our alcohol group, if you will. And so what you're going to do when you name alcohols is we're going to change the ending to all. And so let's just do one. Let's say that we had, again, if we had there's H's here. I'll go ahead and draw them this time. So there's H's there. So again, that's methane. Okay. If I take my methane and I replace one of the H's with an OH, well, there's my functional group. And that's going to change my ending to an all. What I'm actually going to do, I'm going to drop the E. I'm going to drop the E, and I'm going to add the all. And so that becomes methanol. That's what that becomes. It becomes methanol. And so let's do one more example. So let's do 2 carbons long this time. Again, these are all H's here. So that would be ethane. And let's substitute out one of those H's for an OH. So there's my functional group. So now instead of being ethane, we're going to drop that E off, and we're going to replace that E with an OL. Now we have ethanol. Yes, the same kind of ethanol that you would find in gasoline. So there's our ethanol. So adding our OH changes our ending to an all. Now what if we have more than one OH? Let's do that one as well. You should be picking up on patterns at this point. So let's say that we have a propane. I started kind of high here, so I'll do the OH on the bottom. We'll do an OH there, and we'll do another OH over here as well. And so the rest of these are just filled out with H's. And so now we have how many alcohol groups? We have 2 alcohol groups. And so this is going to be, we're going to number, see if I can write here. This is going to be a 1, 3 propane diol. Propane diol, because now there are 2 alls, if you will. You could also bring these numbers in, and you could say, you might see this as propane dash 1, 3 dash diol. You might also see it written like that. Again, bringing the numbers into closer to what it's actually representing. It's representing the diol. Okay? All right, let's do another one. Let's do an aldehyde. Aldehyde. Okay? For an aldehyde, you might see this written, we call those alkanals. And so we end in AL in this case. We're going to change our ending to an AL ending. And so what does an aldehyde look like? So an aldehyde looks like this. It looks like a carbon with a double bonded O and an H. So what we've done is we've taken a carbon that's got, and this is going to go to some other carbon over here most likely, where we've taken off 2 of the hydrogens and taken these 2 bonds that we lost those hydrogens and made it to an oxygen. So that's what you're going to look for as an aldehyde, a C double bond O to an H. And we get an aldehyde. So let's look at the simplest aldehyde, which is going to be this structure right there. So it's 1 carbon, so it's meth, it's methane. What we're going to do, just like the alcohol, is we're going to drop that E, and we're going to add the AL ending. So this methane becomes methanol. That's what it becomes. It becomes methanol. So let's do another one. So here's another aldehyde. And so again, there's our functional group right there. That's our That's our aldehyde group, a C double bond O to an H with an H. So that carbon has a double bonded O and an H on it. We have 3 carbons in this case, so it's propane. Okay, but we're going to drop the E and we'll replace the E with an al. So it becomes propanal. So that's what that is called, propanal. So anytime you see an al ending, we have an aldehyde. So how are these, let's go ahead and go backtrack a little bit. How are the condensed formulas of these going to look? And so let's do the condensed formula here for the dibromomethane. That shouldn't be too hard. So we have a C. Originally these are going to be H's here for dibromo. So we have CH2Br2. Well, that's no big deal. If we did this 2-fluoropropane, well, again, here we got a CH3. And then we have a C, there's an H here. So we have a CH, and then there's an F on that. So CHF, and then another CH3. So that's no big deal, not vastly different. Alcohols, not a whole lot different. So say on this ethanol, this would be a CH3. And then we have a CH2 plus an OH. So there's our alcohol group. And then if we go to our aldehydes, this is how this is going to look. You do need to recognize this. The correct structure in a condensed formula for the CO double bonded OH, you're going to see it as CHO. That's what you're going to see it as. When you see a CHO, that's an aldehyde. And so, for example, this propanal, this would be CH3, CH2, CHO. That's the CHO. It's CHO. That's how you're going to write that aldehyde out in a condensed formula. Okay? So one thing that I want to make sure that you understand with the aldehydes, this is really, really, really important that you understand. Aldehydes are always at the end of a chain. They're never in the middle of a chain. They are always, always, always at the end of a chain. So make sure you understand that. Notice how I'm starring it, and I've circled it, and I'm underlining it, and that kind of stuff. That means it's important. Write that down. Aldehydes are always at the end of a chain. They're at the end of a chain. They're not in the middle of a chain. It's not an aldehyde if it's in the middle of the chain. So make sure you understand that, and always keep that in mind. So aldehydes are at the end of a chain. Okay, let's do one more quick little practice one. Let me have you draw one instead of naming it. So let's say I gave you butanal. Okay, so but means 4 carbons, so do 4 carbons. An al means we have the aldehyde group, which is a C double bond O. H. Now, where did I just say aldehydes are? They are at the end of the chain. So where we're going to put that? We're going to put it at the end of the chain. So put it over here. And now you're just going to fill in with the H's for everything else. And so if you condense this, this would be CH3, CH2, CH2, CHO. That would be your condensed formula for butanal.